Hello, my name is Tammy Miller. In this video, we are going to learn to analyze SN1 solvent conditions. To analyze SN1 solvent conditions, we first have to think about the SN1 reaction itself. An SN1 reaction proceeds through a carbocation intermediate. This carbocation intermediate has a carbon that has a positive charge. The positive charge can be stabilized through hydrogen bonding, and the hydrogen bonding comes from the solvent itself. So we need to think about the solvent. Next, the hydroxyl group on a protic solvent can hydrogen bond. For protic solvents, we can either have a hydroxyl group or we can have an amino group. In either case, these can hydrogen bond. Typically with SN1 conditions, we will be looking for the hydroxyl group. The next thing that we need to think about with an SN1 reaction is that an SN1 reaction does not require a strong nucleophile or a strong base. What this means is that when we use our protic solvent with the hydroxyl group, this hydroxyl group will not be deprotonated by the nucleophile because it is not strong enough. Instead, the nucleophile will attack the carbocation intermediate that is being stabilized by our solvent. Let's look at a question that we can easily think about what type of solvent we want to use. So a student wishes to run an SN1 reaction and needs to choose the appropriate solvent from the three that are available in the lab. Which solvent should she choose and why? Anytime we're looking at solvents in organic chemistry, one of the things that we want to do is we want to be thinking about what does this solvent look like if I drew it out. So we're going to start with Dmso. With Dmso, when we draw it out, we see a sulfur as the main central group, double bonded to an oxygen, and single bonded to two different methyl groups. When we look at this molecule, we see that there is no hydrogen that is attached either to an oxygen or a nitrogen. Therefore, this solvent is aprotic. Because it's an aprotic solvent, we cannot use it for an SN1 reaction. Next, we look at acetic acid. When we draw acetic acid out, what we see is that there is indeed a hydrogen attached to an oxygen right here. That makes this solvent a protic solvent, and because it's a protic solvent, this is a great solvent for an SN1 reaction. Finally, when we look at acetone and we draw acetone out, we see that we have a carbon that is double bonded to an oxygen and single bonded to two methyl groups. This looks just like the Dmso, except for the central atom is a carbon instead of a sulfur. Again, I see no oxygen that has a hydrogen attached to it. Therefore, this is an aprotic solvent and cannot be used for an SN1 reaction. Understanding the solvents that we use for SN1 reactions is going to help us to very easily identify an SN1 reaction when presented to us.